Myself, Professor Sanjay More. Today we are going to learn static characteristics of measuring instrument.
Characteristics of measuring instrument. Static characters refers to the characteristics of the system when the input is either constant or varying very slowly. In other terms, the static characteristics are defined for an instrument which measure the quantities which do not vary with the time. It will keep constant. It will not vary with respect to the time. That is called static characters. The items that can be classified under this heading static characters are mainly range, sensitivity, linearity, hysteresis, accuracy, precision, reproducibility, drift, and static error. Let we see one by one. Range or span. Maximum and minimum values of the quantity for which an instrument are designed to measure is called range or span. Sometimes accuracy of an instrument specified in terms of range or span. For example, for temperature measuring instrument, the input range may be 100 degrees to 500 degrees Celsius. The temperature of the instrument can measure the value of 100 to 500 degrees Celsius. Let me see this picture. This is the span of the instrument, and these two are the accuracy limits, lower limit and upper limit. This one is a real function curve. The values goes like this way. Sensitivity. Sensitivity is the change in output of an instrument to change in input. While defining the sensitivity, we assume that the input-output characteristics of the instrument is approximately linear in that range. For example, thus, if the sensitivity of a thermocouple is denoted 10 microvolt per degree Celsius, for every degree Celsius, there is a change of 10 microvolt. Sensitivity of a spring balance can be expressed as 25 mm per kilogram. For example, while adding a per kg in the spring balance, there is a compression of 25 mm. Again, sensitivity of an instrument may also vary with the temperature and or other factors. This is called a sensitivity drift. Let me see the example. Sensitivity of a spring balance 25 mm per kilogram at 20 degrees Celsius. Sensitivity of the same spring balance 27 mm per kilogram at 30 degrees Celsius. There is a difference of 2 mm for 10 degrees Celsius. So the sensitivity drift is 0.2 mm per kilogram per degree Celsius. So there is a difference of 10 degrees Celsius. So there is a deviation of 2 mm. In order to avoid such a sensitivity drift, the sophisticated instruments are either kept at controlled temperature or suitable inbuilt temperature compensation schemes. Sensitivity is nothing but how the output varies with respect to the input. Linearity. Linearity is defined as ability of an instrument to produce its input linearly. Linearity is simply a measure of the maximum deviation of the calibration points from the ideal straight line. The linearity is defined as the maximum deviation from the linear characteristics as percentage of the full scale output. See this picture. This one is the ideal line. The the output varies with respect to the input, and this one is the real line. It will not coincide with each other because of the error. This linearity is the del O divided by the difference between the outputs. The del O is nothing but the maximum deviation of output. Hysteresis is a phenomena which depicts different output effect while loading and unloading. Hysteresis takes place due to the fact that all energy put into the stressed part while loading is not recoverable while unloading. When the input of an instrument is varied from 0 to full scale, and then if the input is varied from full scale to 0, the output varies. The output at a particular input while increasing and decreasing varies because of internal friction or hysteric damping. Hysteresis is nothing but the output will vary while loading and unloading. Let we see the example. The diaphragm time pressure gauge may be different for the same pressure, but one for increasing and other for decreasing. This one is for increasing and this one is for decreasing. It behaves in two ways. The hysteresis is nothing but the difference, maximum difference divided by the difference between the output. Accuracy. It is a degree of closeness with which an instrument reading approaches the true value of the quantity being measured. Accuracy indicates the closeness of the measured value with the actual true value. Precision indicates the repeatability or reproducibility of an instrument. Let me see this picture. Here the frequency in x-axis and dimensions in y-axis. For example, I would like to make this shaft with the diameter of 25 mm, but the actual value is 25.5 mm. 4 components I have made here, all are very close to each other. So these are very precise but not accurate because there is more error. This one is the actual value, this one is the true value, here is more error. So we can say here this is precise but not accurate. See this picture, the same parameters in x and y axis, here the error is reduced. So we can say it is more accurate but not precise because the values are not close to each other. Reproducibility. Reproducibility is defined as the degree of closeness by which given value be repeatedly measured. The reproducibility is measured for a period of time. Perfect reproducibility will signify that the given reading that is taken for an input will not vary with the time. See this picture. This one is the true value and this is the frequencies and measure values. This one is the local lines and this is the strict line. Reproducibility is in different measuring systems will give the same values, that is reproducibility, and repeatability is nothing but for the shortest time it shows the same value, that is repeatability. Drift is a gradual shift in the indication over a period of time where the input variable does not change. Drift may be happen because of the environmental factor like electrical, magnetic and thermal factors. This drift further classified into 3 types: zero drift, span drift or sensitivity drift, zonal drift. Let me see the static factors. It is a deviation from the true value of the measured variable. It involves with the comparison of unknown quantity with known standard quantity. The degree to which the instrument approaches to its expected value is expressed in terms of the error of measurements.